Hello everybody. Today we're going to take a look at Morse division today with remainders, but I'm going to show you today how to solve division problems using both arrays and area models. So a few things to remind ourselves of because we may not have used some of these terms in a little while. One of the terms that you're going to see popping up today is the quotient. And I just want to remind you that the quotient is the answer to a division problem. Remember, a sum is the answer to an addition problem. Difference is the answer to a subtraction problem. Product is the answer to a multiplication problem. And a quotient is the answer to a division problem. So if you see quotient, they're looking for what's the answer here. Also, a quick reminder of what an array is and an area model. An array are a series of rows and columns to represent either a multiplication or a division problem. So if I had something like 2 times 3, I would do 2 rows of 3. This is an array. Or I could do 3 rows, of 2. That would also be an array. Okay, so these are arrays here. And an area model would be a 2 by 3 rectangle, right, with 6 total squares inside, or a 3 by 2 rectangle with 6 squares inside. So this is an area model. So today we're going to take a look at how we can use an arrays and an area model to solve division. Okay, so we're going to scroll down a little bit here. And we're going to take a look at a pretty straightforward one first. And you'll notice I put my background as a grid paper. If you happen to have grid paper or access to grid paper, strongly suggest you use it for this lesson today, for our activity. So let's say we have something like 10 divided by 2. Now, you guys know how to do this, and you probably, many of you, already know the answer. And that's okay, because I'm just going to model for you what this would look like as either an array or an area model. Okay? So if I wanted to do 10 divided by 2, I can draw 10 x's into 2 equal groups, right? So I'm going to go, here's 1 group, here's 2 groups, and I'm just going to keep going until I get to 10. So I'm going to actually just count by 2. So 2, 4, 6, 8, 10. Here is an array that represents 10 divided by 2. Here's 1 group. Here's 2 groups. How many ended up in each group? And then I can count my x's in each group. 1, 2, 3, 4, 5. My quotient, therefore, remember, quotient, addition, the answer to a division problem, not addition, the answer to a division problem. So my quotient here is 5. I took 10 items, divided it into 2 groups in an array form, and I got 5. What would that look like as an area model? So here's my array. I'm just going to put this in red. Here's my array to represent 10 divided by 2. And then here's my area model. It's going to look very similar, right? Yeah, we'll keep it in red. I'm going to take 10 squares and make 2 rows with 10 squares total. So here's my 2 rows, and then I'm just going to, again, count by 2s to get to 10. So 2, 4, 6, 8, 10. Whoops. So then I can complete my area model, and I'm going to label it as 2. I knew I had 10 in the middle. And then to figure out my missing part, I'm just going to count my side lengths. 1, 2, 3, 4, 5. There you go. And so my quotient here is 5. Right? So when I have something like 10 divided by 2, I can skip count by that, make that many rows, and then skip count until I get to the end. What if I had 11 divided by 2? Let's take a look at how that changes things a little bit. Now, you may already be thinking, well, we know that's not going to work out nicely because 11 is not an even number. And you're right. But we're going to start to set it up the same way. We're going to think how many 2's get us as close as possible to 11. So again, I'm just going to start counting by 2's and making my array. 2, 4, 6, 8, 10, And then I've got this one extra left over. I'm going to put it right here because I have to make sure I have my 11. Here are my two equal groups. Remember, the groups have to be equal, and I have one left over. So my quotient, my answer is what? How many went into each equal group? 5. Don't worry about that leftover right now. The question for the quotient is how many went into each equal group. Then you can write your remainder, and my remainder is 1. I have one extra left over that didn't fit equally into those two groups. And if I look at it in an area model, and so up here I could write 5 remainder 1. For my area model, I'm going to do the same thing. I'm going to get my 2 on the side. I know I have to divide it by 2, and I know I have to have 11 squares. So I'm going to count across. 2, 4, 6, 8, 10. That's going to get me 10 squares, but I have to have 11, so I'm going to stick another square on the side here. I know this is 10, and now I can figure out what my side length is. 1, 2, 3, 4, 5. So this is going to be 5. So once again, I know that 11 divided by 2, my quotient is going to give me 5. That's going to be right here. That missing part that we didn't know. Whoops. I meant to do that as a highlighter. And we still have one extra left over that didn't quite fit. Let's take a look at another one because this is kind of tricky. What if we have 16 divided by 3? Okay, let's start with our array. So what am I going to count by? 3s. I want 3 equal groups. So I'm going to go 1, 2, 3. Now I have to get as close to 16 as possible, so I'm going to start counting by 3s. There's my 3, 6, 9, I can still do more 3s, 12, 15, and I know I can't get another 3 in. If I do 3 more, it's going to make 18. That's too much, keeping an eye on what our total number is here. So I'm going to have 15 here, and I have 1 extra for 16. So therefore, 16 divided by 3 gives me a quotient of how many in each equal group, or how many in each row? I ended up with 5 in each row and a remainder of 1 left over that didn't fit nicely into those equal groups. Now let's take a look at how I would solve that with my area model. I'm going to have 16 divided by 3, so I know I'm going to have 16 of these squares in some sort of form that's going to make a nice rectangle as best as I can. And I know one of my side lengths is going to be 3, so I'm going to make my side length of 3. I know inside has to have 16 or something close to it. So again, counting by my 3s. Or even more efficiently, if you guys know your multiplication facts, and this is why it's so important to know them, you can say, I know 3 times 5 gets me 15, and that's as close to 16 as I can get without going over. So then I can go 1, 2, 3, 4, 5. I can label my inside as 15. That's my area in here. But that's not enough. I need 16, so here's my extra one. So 16 divided by 3 gives me a quotient of 5 and a remainder of 1 left over. Okay? Does everybody see how that kind of works? I'll give you one more example. 38 divided by 4. We're going to get bigger. Okay, again, let's start by looking at an array, and you are going to do both today. And I know it seems a bit repetitive, but this is a good habit to get into. I want you to see the difference between the two and all of their similarities so you can really get in the habit of it. So if I'm making an array of 38 items divided into 4 equal groups or 4 rows, I'm going to start by making my 4 rows. Remember, rows go this way. Whoops. Sorry, didn't know it would do that. Rows go this way. So I'm going to set up my 4 rows and then just count by 4s until I get as close to 38 as I can. I know 4 times 7 is 28. So I know that I'm going to have at least 7 columns. So I'm going to go 2, 3, 4, 5, 6, 7. That's 28. Plus another 4 is going to be 32. Plus another 4 is going to be 36. Ooh, I can't fit another 4 in. So 37, 38. Now I'm going to just double check and make sure I got that right. I'm going to count by my 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 37, 38. I do have all my 38 X's. Now I have to think about how many fit into each equal group. What is my actual quotient? Remember, they want to know if you have 38 of these, how many equal groups or how many in each equal group will you get? So I'm going to count these. How many in each equal group? Not my extras. I'm going to see how many equal groups, right? Or how many in each equal group. 1, 2, 3, 4, 5, 6, 7, 8, 9. My quotient is going to be 9. And my remainder is going to be 2. I have 2 left over. Here's a great way to check. I know 9, my quotient, how many are in each group, times 4, how many groups I made, is equal to 36. And then 36 plus my 2 remainders equals 38, my dividend. Okay? So you can always check by using multiplication. Let's take a look at what it looks like if we do an area model. And I'm going to move it a little higher so we don't run into any problems. Again, I'm going to draw a rectangle, and I know, let's see, I'm actually going to take this part, and I'm just going to make it smaller even though it won't fit in the squares anymore. Put it over there. I know for my area model, I have to have a total of 38 of these squares, and I need to have a side length of 4. So I'm going to start with my side length of 4. 1, 2, 3, 4. I'm going to label it. I also know that I've got to get 38 squares. So once again, I'm going to count by my 4s. 4, 8, 12, 16, 20, 24, 28, 32. Uh-oh, I ran out of room. I'm going to just move this over. Boop, 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 boop. Let's try this again. So I'm just going to kind of go again. 4, 8, 12, 16, 20, 24, 28, 32, 36. That's as far as I can make it without going over. I'll erase my little lines here. And that's 36, and I know I need to have 2 more to make 38. So I know that made 36 when I skip counted. And now I'm going to check what my side length actually turned out to be. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I can label my side length. And remember, that part, that's your quotient. So my quotient is 9. And I have a remainder of 2 left over that don't fit nicely into that neat rectangle. So when we're using our area model, the goal is to try to make this as big of a nice even rectangle as you can, and then tack your extra remainders on as needed. Your job today is to go and do several problems like this. You're going to show an array, and you're going to draw an area model as well. It is very important you draw both. You label your side lengths. Okay? You've got to show it as I've shown it. And there's also an example in the assignment. So they've shown you kind of a visual. On some of the later problems, they do not give you a grid for making your area model. You don't necessarily need a grid. If you have drawn your array, you should be able to make an area model that matches nice and easily. Take a look at my little array right here. My array. If I look at my array, I can easily make my area model without even having to do skip counting. I know I'm going to have a 4 by 9, so I would immediately just draw a rectangle, label it 4 and 9. I'd multiply those. I know that's 36, and then I notice that I've got 2 left over, so I'm going to make this and show that that's 2 left over. And in fact, you should probably do it like this, okay? To show that you've got your 2 left over. So when you make your area models on your assignment, you don't have to make a grid. You do not have to draw all the lines in between. If you're working on grid paper, that is fine. They'll already be there for you. But you don't have to have that. You can just draw an area model like I just showed you here in the purple. Good luck. Let me know if you need any help.